Hello everyone, in this video I'll teach you how to use C#'s get and set feature in Unity. You probably know that you can make a variable public or private, right? But what if you want to make a variable publicly readable but only editable from the script itself? This is where fields come into play. Think of it like a private variable and a public method that returns just a variable. You can even execute other code while returning the variable. This can be useful as we'll later discuss a few patterns like the self-initializing singleton. Sure, this works, but it's clunky. Having to write the method just to return a number feels unnecessary. That's why we have the get and set properties in C#. We can create a public property, give it the public getter so it's accessible by other scripts, and a private or protected setter so only the class itself can write to it. We don't call x a variable anymore, but a property. This doesn't directly hold the value itself, but it acts as a wrapper that returns the backing field, which is the variable in memory. In earlier C# versions you had to manually create the backing field and return it in the property. Nowadays you can just write the shorthand and C# automatically generates the backing field. If you decompile your code with something like JetBrains .peek, you can actually see that the compiler expands your high-level shorthand into the low-level code with a private field. So in a way, properties are just syntactic sugar on top of normal fields. Even though this is valid C# code, we can't directly apply it to Unity. At least not if we want to edit the variable in the inspector, because auto properties can't be serialized by Unity. We need to manually create a backing field and add a serialized field attribute in front of it, so you can edit it in the Unity editor like a normal variable, but still have the benefits of a C# field. To get to naming conventions, you should write your properties in Pascal case, while private backing fields are usually written in Camel case or with a leading underscore. We can even add custom logic to our fields. Here, every time the property is accessed, the counter increments by 1. It doesn't matter where we read from it, the logic is always executed, except if you access the backing field directly, the getter and setter won't run. That's why you should always use the property, otherwise you'd be skipping your own rules. Properties also let us validate or clamp values when setting them. In this example, no other script can set your health to 500, if 100 should be the maximum. You could also add logic when it reaches 0, for example calling a die method. You can find many more examples in the Microsoft documentation. Now to get to our more advanced examples, the self-initializing singleton. You probably know the normal singleton pattern in Unity, where a class has a static instance of itself that you can access from anywhere. Usually you add some logic to prevent multiple instances, as the whole point of a singleton is that there's only one in the scene. But there are some singletons that we don't need always when we are playing the game. For example, in my game I have a self-initializing singleton that I use to make bug reports. It would be wasteful if this was always persistent, since players won't file a bug report every session. This is a perfect case for a self-initializing singleton. It only initializes itself if some other script actually accesses the instance. In my game I have a mix of persistent singletons, normal ones and self-initializing ones. Think of it like another tool you can use wherever it fits. That's it for the tutorial. If you have any questions, feel free to ask me in the comments, and I wish you all a great day. Oh, and I almost forgot to mention, I'd really love to start doing some coding live streams, but I'd need to hit 1000 subscribers first. So if you'd like to see that, please consider subscribing. It would really help me out a lot, and thanks so much in advance.